Okay, so for the last part of this module, I want to talk about sort of how we visualize some of these geographic patterns. If we're talking about what are the fundamental geographic implication, or not even really implications, but fundamental geographic patterns in biogeography, how do we visualize some of those geographic trends? Because the visualization has a huge impact on how we conduct biogeographic research and what sort of trends we are able to find in the first place. So it's a big component of any sort of, and not this isn't just specific to biogeography. These are probably concepts you've run into if you've taken any sort of geography course. So hopefully you saw that video. I think I always like to include that Vox video of projections. I think they do a really great job of sort of walking through what is kind of a complex thing, and you've probably seen that video or gotten this lecture if you've taken a geography course before, but it's always worth walking through it again just in case you haven't, or just to refresh your memory. So when we make a map, any kind of map, definitely biogeography maps, any map you've ever seen, we're going from a three-dimensional surface to a two-dimensional one. And like you saw in the video, the issue there is that it's impossible to do that without introducing some sort of distortion, because you're losing one of the dimensions, so that you can't have a perfect representation of a 3D shape or entity in a two-dimensional format. It's just impossible. It's mathematically impossible to do. We're getting better and better and better at minimizing that distortion or spreading it out equally, but it's ultimately not. You just can't go from 3 dimensions to 2 dimensions without losing or distorting something. And I'm not going to get too much into this. As far as what types of distortions there are, but it's just worth mentioning that there's lots of different projections and there's lots of different ways that you can represent Earth's surface in some mathematical, you can transform it in some mathematical way, and it's going to distort your map in some different kind of way. And I don't want to reiterate what was in the video or what you may have heard already, but it's just worth mentioning that there's lots of different kinds, and it depends on what you're trying to do. If you're trying, for like Google Maps does, you're going to want to preserve like direction and things like that, and you might be able to distort different things. It depends on what the purpose of the map is going to depend on what sort of distortion you're going to allow or you don't want to allow. Obviously, you want to minimize distortion whenever possible. Ultimately, maps are simplifications, and this goes really for maps are a type of data visualization, especially now. We're not really making maps for navigation anymore. So maps are really about visualizing some data trend, and so essentially we are simplifying the real world in order to show some trend that we want to emphasize. So all maps are these simplifications. And that has these implications for what type of map you're going to create. You can there's sort of scales that you can work on here. You can create a really highly accurate map that has relatively low simplicity. And I think this is a good example of that, where this is the geologic strata of England and Wales, like the basically the UK, I think. And this is an older map. It basically is just showing like different types of geology across those islands, and it's highly detailed. So there's tons and tons of detail in here, and if you could zoom in, you'd see all sorts of stuff going on this map, and it's highly representative of what's actually going on in the real world in terms of the geology of this area. So it's highly accurate, and in that sense, it's not very simple. Like there's a lot of detail in here. You can't really look at this map and say, oh, I immediately know what's going on there. There's a lot of stuff. It would take you a while to really wrap your head around what's going on here. I mean, it's showing you the geology, but is there some trend here? Like, I don't even know. Just looking at this, there's so much. It's kind of messy. And that's not necessarily a bad thing. It's just that the intent of this map was to represent in a very accurate way this specific thing, which happens to be the geology of this area. So this is an older map, but it's a good example of that. But you don't have to, not all maps take that approach. These are, I'm kind of showing you like some famous maps here, old maps. This is something you might not consider a map, but this is a map of, I'm gonna not remember, Mount Trimbazo. Anyway, Alexander von Humboldt, who's sort of the most famous biogeographer ever, made this map, and it's basically it shows the vegetation and some other information about this mountain. So basically, how these vegetation types change over elevation, and it's sort of like a painting almost, like it's kind of a weird thing, but it's one of the most famous maps, and it sort of sits somewhere in between on these scales where it's moderately accurate, you know, like it's not, it's sort of stylized in some way where if you know you don't really expect the elevation to be exact in here, and you know it's just sort of a representation of it, but it's still like in a relative sense it's probably pretty accurate, and where you're going to have certain types of vegetation here and certain densities, and as you move up, and that information is sort of showing over here if you could zoom in here. And it has moderate simplicity, so it's not so detailed that you can't really wrap your head around what's going on. Like you can see like, oh, this is a mountain, and I can see how that's changing as you move up in elevation, and there's some other ancillary information here that's going to make that a little more clear. So it's not like the most simple thing you've ever seen, but it's sort of moderate in terms of those two scales. And so this is, I hadn't seen this until I got this new version of the textbook that I'm using for this, and I'm not requiring you guys to have the textbook, so you probably haven't seen this either. But this is basically the graphical model, like the first graphical model for island biogeography. And we haven't talked about that. We're not going to talk about that until later in the semester about what island biogeography is, but it's basically this theory for understanding how many species are going to be on an island, and that's related to some different things here. And you don't really need to understand all of that. What I'm trying to point out here is that this is a very low accuracy visualization, to the extent that you wouldn't even consider. I mean, this isn't a map. This is just a figure, you know. So it's highly simplified. In the sense that it's very abstract. So it's not really representing anything specific, but rather just some relationships between these two things. And in that sense, you know, you can easily look at this and say, you know, this is probably the area of the island, or something that's on the y-axis here. Obviously this is just written out. Like when we talk about it, we'll see some actual like professional looking figures so you can understand it. But you know, you can sort of see like, oh, this line's going up, and if I knew what was on this axis here, I would be very clearly able to understand what this relationship is. I just thought it was interesting because I'd never seen like the handwritten version of this, which is kind of cool if you're like a science nerd like I am and interested in these things that probably aren't that interesting. But anyway, the point is that it's really low accuracy. You know, it's not showing you a specific island and where species are on the island or anything like that. So it's highly simplified, and it's just showing this relationship. So that's sort of the dichotomy of data visualization and making maps, where we're simplifying the world in some way. No matter what sort of map you're looking at, it's not showing you every single thing. You know, that's impossible. And so you can try to show as much as you possibly can and have a very detailed and accurate map, but low simplicity. Or you can abstract things and try to show just one simple relationship in a very abstract way and have it be highly simplified. And there's different uses. Neither one of those approaches is good or bad. It just depends on what you're trying to do. Something that, oh, my picture, yeah, it's a little ugly. My picture didn't quite scale here the right way. But in terms of visualization, visualizing data and analyzing data, we've seen a huge explosion recently in terms of GIS technology, which is Geographic Information Systems, basically computer software that allows us to manipulate and analyze and visualize spatial data. And if you've ever turned on the news, I mean, the whole past year, we've been blasted with maps of coronavirus and things like that. And so you're sort of getting a firsthand view of that. But we see these sorts of maps all the time, and we're getting better and better at using spatial data. And GIS has been critical for the development of biogeography. And not just biogeography. I mean, GIS in itself, as a discipline in itself, has been exploding. So this is just showing you the number of journal articles which mention, using GIS in the methods, some form of GIS in the methods, and this is just sort of exponential growth since the mid 90s, or I guess since the early 90s, since the development of the technology really has just exploded. And this is even, outdated. I mean, it'd be up here if we wanted to scale this out to 2021 now. But yeah, just showing you how quickly GIS has taken over, and it allows us to do all sorts of things. And we'll talk about some of those things in terms of like species distribution maps and geographic ranges. I mean, I've already shown you maps that utilize GIS technology. So it's a very important aspect of biogeographic research, and so I'm going to have you do some reading on that. But I forgot. I'm getting ahead of myself here a little bit. So cartograms, we're talking about GIS and mapping and things like that. One of the ways we visualize some things are using cartograms, and the textbook really highlights cartograms. Maybe this is something, I don't always do biogeographic research. I don't use cartograms a lot, but maybe this is just something specific to biogeography. But cartograms are maps that intentionally distort a property of the map in order to show a trend or pattern. So here you're seeing biodiversity. I think this is just species richness, like the number of species in these areas. So they're distorting area, and that's probably the most common way, the most common property that's going to be distorted, usually area. I don't know what other property you might want to distort. There's probably maps out there that have distorted other properties, but usually area, because it's just super easy to look at that and say, oh, there's a lot of biodiversity in South America and in certain portions of Africa and even in Asia. Endangerment, you can see there. This is sort of a funky one, but what levels of endangerment, like how many species are endangered, some form of that. Discovery rates, like where are most of the new species being discovered. So just different ways of distorting the map on purpose, intentionally, in order to show some trend. And it's effective. I don't see too many like published maps in like journal articles that have been published that are cartograms, but you see them from time to time. I think they're more popular in sort of like popular science and news media and things like that, but still worth mentioning. Okay, so I'm going to wrap up this last video here. Keep working your way through the module. There's another reading called this is the Reimagining the History of GIS, which sort of walks through what the actual history is and how we're sort of shoehorned into some technological limitations and certain types of limitations based on choices that we made during that time. And it's sort of a different perspective, but also gives you a history of the development of GIS as a science and as a field. So working your way through the module. This is the last video of this module, so I will see you next week. And as always, let me know if you have any questions about anything. You can email me or shoot me a message on Canvas. And just to reiterate, we're going to be using the same format next week. We'll be online, and if that's going to change, I will be sure to let you know well ahead of time if that is going to change. So anyway, keep working your way through this, and I will see you next week.